Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Afiq Aiman and I'm from Group 1. And today I would like to give some explanation about the topic rounding significant figures and decimal places. Okay, here we go. Bismillahirrahmanirrahim. All right, this is I introduce to you our team for this chapter. And the first one is, of course, is me, Afiq Aiman, and my teammate is Khadijah Hana and Nurin Zulaika. Okay, next we proceed. Okay, the first one is rounding. What is the meaning of rounding? Rounding is replacing a number with an approximate value that has a shorter or simpler. It means when we make some calculation, whether we need to calculate the moles, volume, or mass, and the answer will given the very large values. For example, it might be 1.00123, so it's very large, right? And rounding make them become shorter and simpler. That means the answer will be a few digits, but it will give the same value. All right, and the value is not very accurate but easier to use. Okay, next we proceed. Okay, rounding also have their own rules. So and we call the rules of rounding. Okay, the first rule is plus one. Why we need to plus one? If greater than 5. So if the first non-significant figure is greater than 5, the last significant need to plus 1 or add 1 and drop all the significant figures. And rules 2 is plus 0 if lower than or less than 5. If the first non-significant figure is less than 5, drops all the significant or plus 0. Yes. So as you can see, there are some example here. Okay, let's see this example. Okay, the number given is 2.1165, right? Okay, and the question wants to rounding for three significant figure. Okay, three significant figures. So we take note that the question wants three significant figure, right? Okay, so as you can see, the number two become the one significant figures, and the number one become the two significant figures, and the one here become three significant figures. After three significant figures, the rest will become non-significant figures. So the number six will become the first non-significant figures. Non-significant figures. All right. So how the process of rounding? So we see that after we mark that the number one is the last significant figures, and we see the first significant figures is number six. Is it six is greater than five? Yes, it's greater than five. So what do we need to do? We need to plus one at the last significant figures, which is number three. All right, is number three is the last significant figures. We add one, and after we add one or plus one, we drop all the non-significant figures or throw them away. Okay, and the answer will be like this. All right, will be like this. Okay, become 2.12 after rounding into the three significant figures. All right. Okay. Next, I would like to tell about the application of rounding in chemistry. Rounding in chemistry, usually we use rounding when we in the laboratory or we make some calculation of moles, volumes, and mass, or something else that give large values. We highlight that they give large values. Rounding will simplify the number, become shorter and easier to use. All right. Okay. And this is some example related to the question. Okay, the question is calculate the moles of 0.25 gram of natrium and round your answer into two significant figures. Given molar mass of natrium equal to 23.0 gram per mole. Okay, the first one, how we can solve this problem. The first one, we make sure that what is the question one is calculate the moles, right? Calculate the moles. So we recap the formula of calculate moles, which is N that symbolize moles equal to mass per gram, mass per molar mass. All right, and the mass that given is 0.25 gram of natrium and divided by the molar mass of natrium, which is 23.0 gram per mole. And after we divide it, we can get 0.0108 moles. Okay, that's not the final answer yet, but we see here the question wants us to round your answer into two significant figures. After we round it, so we need to round into the two significant figures, right? So the answer here 0.0108, we round into the two significant figures and we can get 0.012 moles. And the final answer is 0.012 moles. All right, okay, that's all from me. So we proceed for the next member. Thank you.
Next, we move to the introduction of significant figures. Okay, what's meant by significant figures? Significant figure is a digit that carry meaning in a number and contribute precision. We move to the rule of the significant figure. First, all non-zero numbers are significant. For example, 33.2 has three significant figures. Number 2, 0 between two non-zero are significant. For example, 2051, it has four significant figures. Number 3, trailing 0 to the right of decimal are significant. For example, 92.00 has four significant figures. Number 4, trailing 0 in whole number with decimal shown are significant. For example, 540 dot. It has three significant figures. And lastly, for number notation, and multiply 10 to the power of x and are significant. For example, 5.02 times 10 to the power of g. So it has three significant figures. We move to the importance of significant figure in chemistry. First, to take the accurate data in laboratory. Second, to have precision of your measuring instrument. We move to the question number 3. A sample of some metal weight 39.15 gram when placed in a graduated cylinder filled with water up to the 16.6 milliliter marks, the new volume reads 20.2 milliliter. What is the density of the metal? Density, as we know, density is mass over volume. So we found the volume 20.2 ml minus 16.6 milliliter. So it will get 3.6 milliliter, same as 3.6 centimeter cube. So we can find density from mass over volume, which is 39.15 gram over 3.6 centimeter cube. So we can get 10.875 gram per centimeter cube. So we round off to the two significant figures and we get 11 gram per centimeter cube. Question 4. The gas occupies 5 liter at temperature 26 Celsius. If the temperature is raised to 350 Celsius, calculate the change of the gas at constant temperature. So as we know, constant temperature is shown by Charles' law. So we use V1 over T1 equal to V2 over T2. So with V1 we has 5 liter and T2 we have 26 Celsius. So we should change the Celsius to the Kelvin by adding 273.15. So we get 299.15 Kelvin. For the T2, we have 350 Celsius. So we change to the Kelvin by adding 273.15 Kelvin. We get 623.15 Kelvin. So we solve the x and we get x is 10.41534 liter. So we want the change of the gas. So 10.41534 liter minus 5 liter, we get 5.41534 liter. So then we rounding it by three significant figures and we get 5.42 liter. We're rounding the answer by three significant figures because we want to use the measuring instrument.
Hi everyone, my name is Khadijah Hannah binti Kahar and my metric number is 1212920. So I will introduce about the decimal places. So what is the decimal places? Decimal places has the decimal point. So what is the decimal point? Decimal point is the position of a digit to the right of decimal point. So what is the importance of the decimal places? The correct number of decimal places is used to indicate the correct position when adding or subtracting. So if in the experiment, example, if we measure the volume of the solution, the result has been in decimal places to obtain more accurate measurement. So we move to the first example. Using a graduated cylinder, you measure out 11 ml of water, then you go to analytical balance and find the water to weigh 11.9273 gram. What is the measured density of the water? To correct number of significant figures. So here the possible answer A, B or C. So the explanation here, as we know, the formula of density is wave per volume. So 11.9273 gram per 11 ml. So the answer is 1.08430 gram per ml. So when dividing two numbers, the answer can only have as many significant figures as the number with the fewest significant figures. The mass have 6 significant figures while the volume has 2. Therefore, the answer can only have 2. Don't forget to round it. So the final answer is 1.1 gram per ml. So the answer is B, 1.1 gram per ml. So we move to the second example. Calculate and give the answer using the correct number of significant figures of the decimal. Okay, this is the question about decimal places, right? Okay. So here the possible answer A, B or C. So we look to the explanation. First, add up all the numbers. Okay, as you can see, 1.02 kilogram plus 8.2 kilograms plus 3.33 kilograms and 9.781 kilograms. So we can get the answer is 22.331 kilograms. Because this is addition, the result of the calculation needs to have the same numbers of decimal places as the number with the fewest decimal places. Since 8.2 has least number of places after the decimal point, the answer must also only have one digit after the decimal point. So it will become 22.3 kilograms. So the answer is A, 22.3 kilograms. So that's all from me about the decimal places.